Hello and welcome. Today, again, we are going to talk more about matrix multiplication. Now, these are the questions that I posted last time. Now, let's start there. Can you find two non-square matrices A and B such that AB and BA exist? Now, you just need to find two matrices such that AB exist and BA exist. So, see if A is m by n and B, in order for AB to exist, B must be n by p, right? Now, this number should be the same. So, let's say A something by 2 and B 2 by something, right? For example. And then in order for BA to exist, now B is n by p and A is m by n. These numbers must be the same. So right here and here. So as the answer for this question is, as long as you have a matrix A something by something and another matrix B something by something. Let me use some colors. As long as this guy is same as this and this guy is same as this, both AB and BA must exist. Now let's have a look at that. So let's take an example, 3 by 2. So this is 3 by 2. Let's call this A. And B 2 by 3. Two by 3. Now, if I want to find AB, okay, 3 1 1 1 0 2 and B 4 2 0 1 1 1. So 3 by 2, 2 by 3. See, the numbers exist. So yes, we can do that. And the result in matrix is 3 by 3. So, and if I want to find BA, what I would do, I would write it other way around. So 4 2 0 1 1 1. This is 2 by 3. And A now 3 1 1 1 0 2, which is 3 by 2. So these numbers they agree, but this time the result in matrix is this one times this one, so 2 by 2. And I'll leave it for you guys to find these two matrices, and I'm pretty, let's do that. So 3 1 and 4, let's see, 12 14, and then with this guy 6 8 and 0 1, and now I'm done with first row. The second row now 1 1, that's easy. So 4 1 5 2 1 3 1, and with this 0 it's easy. So 2 0 again 2 2, and this one 12 2 14, and with this 4 2 8, and now with this 1 1 1, so it's easy. 4 1 2, so 4. See, two different matrices. Actually, they are of two different sizes. Now, what was our next question? Next question was, well, the same thing. Can you find two non-square matrices A and B such that A, B and BA exist, but this time I am forcing them to be equal? Now, this is a nice question. Can you do that? So let's see that. So the question is, you have to have AB must exist and BA must exist. And not just that, AB, BA. Now see, we saw as long as these numbers, for example, let's say 3 by 4 and 4 by 3. In this case, AB will exist. Not only that, BA will exist. But if you find the size of AB will be 3 by 3, but the size of BA would be, when you switch it the other way around, it will be 4 by 4. Now, if you need this condition, this will force these matrices to be square matrices. That means this number is this number, this number is this number, but if you have this as well, it will force all these four numbers to be equal. So this A and B must be square, otherwise it does not work. So for the question number 2, the answer is no. The last question I posted: find two square matrices of the same size such that AB equals BA. Now let's have a look at that. Same size. AB equals BA. So AB equals BA. In general, this is not the case. So we are playing with this commutative property. AB equals BA. Can you find two square matrices? And I think I have given you condition. None of them should be identity matrix. Now it makes it difficult. Because if one is identity matrix, that is the perfect example where this happens. That is one case where this happens, when one of them is the identity matrix. But can you find one without an identity matrix? Okay. How about this? There is one way. Let me... So trivial solutions. One trivial solution is actually the one that I am asking you not to do. So, but let me burn it. Either A equals I or B equals I. In that case, AB always BA, right? When I say I is of the same size as A or B. There is another way, another two ways actually. What if I make A, for example, 1 by 1 matrix, 7? What if I make B 8? 8 times B, 7, 8. So 1 by 1, result is 1 by 1, that is 56, right? And B times A, 8, 1 by 1, 7, 1 by 1, you can multiply, result is 56. Matrix, still matrices 1 by 1. So see, that's a trivial solution. There is another way. What if I make A equals B? In that case, see, you can take any square matrix and so A is this, B is also this. So AB is actually A times A, which is normally known as A squared, and B times A, B is A, so A squared is the same. If you find whatever, it's going to be the same. In this case also, AB equals BA. So all these three cases are trivial solutions, trivial cases. There is another way when we talk about inverse. So I'm not going to show that to you. There is another way, but I will leave that question open. Can you play with numbers? Let's say 2 by 2. 2 by 2 is the easiest case. Can you play with some numbers and find, X, Y, Z? You can use letters, numbers, whatever. Find two matrices such that AB equals BA. So I will leave that question open. Okay. Now we'll do more interesting problems. Okay, I'm telling you A is this, B is this. I want you to, let's say, and given BA equals 1 by 1 0 matrix. Find AB in terms of little a. Actually, this question has something to do with what we did few minutes ago, the first question that I asked you. Because if you see A is 2 by 1, oops. Okay, because if you see this, A is 2 by 1 and B is 1 by 2. See, the orders are reversed. That's why BA exists and AB exists. Okay, now BA. You know, when you watch these videos, the best way to learn, use the pause button. So at this point, I recommend you to pause the video and try it yourself and then come back and watch it. Okay, assuming you have done that, BA, B is B2 and A is negative 1, A. So when I multiply, see 2 by 1 by 2 into 2 by 1, the result is 1 by 1. See, it's 1 by 1 here, right over here. But using this, we know negative B plus 2A, that's our answer, and that should be 0. So this forces negative B plus 2A equals 0 and B equals 2A. Now AB, when I put A negative 1, A and times B2, this is 2 by 1, this is 1 by 2, and I'm getting this first entry will be first row. So you have to be careful in this example. First row is this. By first column, just this one, negative B. First row by second column, this by this, so negative 2. Second row, this by this, so AB. And second row, second column, 2A. Now the question says in terms of A, so you just need to replace B by 2A. So negative 2A, negative 2, A times B, so A times 2A, 2A squared, 2A, this is the result. This is the expected result. Okay, how about another example? Let's say A equals 1, negative 1, 2, B equals 3, negative 2, C equals 4 and 5. Question, find BCA. Can you do that? First of all, does that exist? Now 3 multiplications. So if it exists, so let's have a look at this. Again, pause the video, try it. So B times C. B is 1 by 2 matrix. C is 2 by 1 matrix. So yes, these numbers agree, and the result BC, that is 1 by 1 matrix. And BCA, see, BC is 1 by 1 matrix, A is 1 by 3 matrix right over here. So that's why BCA exists. I think that existence part is clear, right? Now let's actually simplify this and see. Now there are 2 ways to do this. I would first find BC. So B is 3, negative 2. C is 4, 5. So the first row, B has only one row actually. So this by this, so 1 by 1 matrix is the result in case. So 4 into 3, 12 minus 10, so 2. BC is just this. And BCA, this BCA is actually BC times A, right? So that's what we did. We first found BC. Now I am going to find that, because see, BC is this 2. And now I'm going to put A here. A is 1, negative 1, 2. So let's see the sizes 1 by 1 and 1 by 3. See, sizes work. So the resultant must be 1 by 3, these numbers, right? So the first row, this one by this, so 2, this one by this, so negative 2, this one by this, 4. That is the answer. 2, negative 2, 4. Now there's another way. What if somebody try to do this? Find this first, CA, and then multiply it with by B. On this order, you must get this. Let's check that. So BCA, in this case, what I'm going to do, B times CA. So first I will find C and A. My C, 4, 5, and my A, 1, negative 1, 2. So this is 2 by 1 matrix. This is 1 by 3 matrix. See, the numbers agree. The result in one would be 2 by 3. So 2 by 3. So first row, this one by this 4, this one by this negative 4, this one by this 8. Now this one by this 5, this one by this negative 5 and 10. See, 2 by 3. Now BCA. You already know CA. So first put B. B is 3, negative 2. CA is this guy, so let's put it here. 4, negative 4, 8, 5, negative 5, 10. Actually, this method is little bit harder than the other one because a little bit more. Here you have much larger matrix. This is 2 by 1. No, sorry, 1 by 2. And this is 2 by 3. See, the numbers matter. And the result in matrix is 1 by 3. Let's see. So the first row, only one row by this one. So 3 into 4, 12, minus 10, 2. Then this by this. So 3 into negative 4, negative 12. And minus 2 into minus 5, plus 10. So negative 12 plus 10, negative 2. And this into this, 3 into 8, into 24, minus 20, so 4. 2, negative 2, 4. Is that what we got? Let me check. 2 negative, see, there they are the same. And I think that's enough for this video, but I believe I should do a little bit more nice examples, and let's do that in next video. Thank you.